Welcome everyone. Today we have our another new episode and we will discuss on NASA James Webb Space Telescope, especially from the youth communities. They are very much interested about to know more about this issue. So we have our world famous speaker, Professor David Smith and Mr. Adam. Professor David Smith also working with a NASA projects. Hopefully he can share his experience with our audience, and through this process our developing nations audience can understand what is happening inside NASA and how does it work. Professor David Smith.
Well, Sharif, thank you for allowing me to talk about this. And I will start broadly and then come into the James Webb Telescope. And what is so exciting about things like the James Webb Telescope and space in general is it really is humanity's next exploration. It's the next big unknown. And our worldview of the possibilities in space has changed so dramatically the last 5 years. Uh, and this type of programs have so many spin outs that go to do other things in our world that it's just amazing. On the James Webb Telescope, it itself is a remarkable instrument. Um, it was built in a partnership between NASA, the European, and the Canadian space agencies. The contract out to do the work to put the components together involved dozens and dozens of countries. So it is truly a collaborative international effort to build a telescope. And the cost to build it was $10 billion with a lot of redesigns, missteps, and things along the way. But to kind of put it in context, uh, the James Webb Space Telescope is the largest and most complex space science observatory ever built to date. And it is working really to advance the new place in the world. Um, it is designed to study every phase of the 13.5 billion years of cosmic history, from within our own solar system to the most distant observed galaxy and everything else in between. Um, it is, like I said, truly interesting. The We have seen the first images, and they're remarkable. When you compare the Webb images to the Hubble images, it looks like a kindergarten's art to a professional painter's art. That much difference as you see them. Uh, but there's some things that are beyond just the pure visible part. Uh, the Webb telescope has an unprecedented sensitivity to infrared light. And that is key for us understanding how the galaxies were built and put together. The Webb will see through dust clouds and where stars and planetary systems are born. And we've already seen new science of the very preliminary initial imaging come out to support that. And we're going to learn about our own solar system. The images of Jupiter that were released at the end of last week make the early ones of even a year ago pale in comparison with what they do and where they are. And so the questions that are trying to be answered with the Webb telescope is, how did the universe begin? How do galaxies form and how do they evolve? And really the ultimate question is, where do we fit in the scheme of this? So the first images came back on July the 12th. The mirror itself is really neat, even though a micrometeorite has permanently damaged part of it. There's 18 segments of it. And that big mirror is over 21 feet across. And that's kind of very interesting. It's designed for a life expectancy in space of doing the science for greater than 10 years. And this is the part that kind of gets me. It has already traveled over 1 million miles since it was launched. to go and be put into the point where it is now in space. And so to me, that's one of the most interesting things about it. The science is just amazing. The team supporting it is amazing. But the collaboration of the multiple countries coming together to create this science first gives me more hope than anything else. So, Sharif, that's my first comments.
Thank you, sir. Now I request Mr. Adam. Mr. Adam, what you want to discuss about this NASA James Webb and especially how the youth communities they can learn more about the process and about the research objective of NASA.
Thank you, Sharif. A bit closer. Uh, when the latest deep space images from the telescope came through and were revealed to the public, I just knew it would give people ammunition saying it is fake. CGI, I'm sure some of you have seen this. CGI, part of a chain of theories concerning space. First, the where they say the moon landing, where um, people say that was fake and we never went to the moon. It was staged, and some people think it was directed by Stanley Kubrick. Then it was the resurgence of flat Earth, which became part of a larger space is fake theory. Um, for the record, I do not think the James Webb images are CGI, nor do I think they are fake in any way. And because of this, the only way I could picture CGI's involvement would be to scrub out photobombing UFOs and space stations. But yes, I don't think it's CGI. What would be the point? Not only do I believe it's not CGI, I don't think they're fake in any way. And I don't support flat Earth either, and I certainly don't support space as fake theory. Um, you can prove that space is not fake with your very own telescope and equipment. You can make your own time-lapsed videos of the stars' movements, construct your own radio equipment to listen to pulsars, observe the Earth's curvature and plane, DIY a laser bouncing off the mirror that they left on the moon, and so on and so on. So I think flat Earth and space is fake are psyops, really. And I'm certainly no materialist atheist either. Before people jump to conclusions, could I be mistaken and the one who is in the wrong here? Of course I could be, but I don't believe any of these tropes for a second, for what it's worth. Um, the millions of astronomers and astrophysicists working hard to bring back these images and sounds for our benefit, for the benefit of all people, would have lots of things to say here with these crazy theories. Past generations of sailors and seamen who are guided by the stars would also have something to say, no doubt. And regarding youth communities and younger generations of people thinking of going into these fields, David Smith highlighted a good point that yeah, these projects are so complicated and multidisciplinary that it requires collaboration on a global scale. Um, so that's like the Star Trek vision of space, where space exploration gives people time to reflect on what's really important, and that one of the most important things is collaboration. So I think if we keep inspiring young people, a lot of the divisions that keep us apart will start to dissolve more and more, I think. So those are my first thoughts.
Thank you, sir. Mr. David Smith, I know that you are also working with some projects in NASA, especially you are trying to solve complex problem. So how does it work? What type of experience you are getting and what you want to share for our audience?
Well, one of the projects I recently did with NASA was looking at wicked problems. But even before that, wow, uh, 25 years ago, I was involved with Dr. George Kosmetsky and some others with setting up the first NASA technology transfer centers when Dan Golden was the executive of NASA. And so NASA always has been in the place of sharing their science, sharing their technology, and transferring it out. Um, some of it was great science. Some of it was necessary, but not very good. The one that most people talk about is the powdered drink that was put together to be able to use in space called Tang. And yes, it was nutritious, but boy, did it taste weird. And as a kid growing up, I got to experience that, and I can still taste it to this day, even though I don't even think it's in the stores anymore. Um, as we talked to him about wicked problems, and wicked problems and grand challenges and VUA problems and others go hand in hand. And that's what organizations like NASA and other space agencies and things are designed to do is look at the big problems, pull together a hypothesis about how it can be solved, work with others to test that, and put in place tools and processes and procedures and collaborations where group intelligence can be brought to bear to look at those problems and begin to solve them. When Apollo 13 had the explosion on the way to the moon, what immediately happened was teams were pulled together inside NASA and outside of NASA to assess what can be done to solve that emergency. Simulations were done. Today we might call it digital twins, but that was before there were digital twins. And they came up with solutions that allowed them to not die in the voids of space and to return to the Earth safely. Um, that is the type of things that organizations like NASA and others are part of their key message space. Now, I'm a Trekker, Star Trekker, I have to admit that. But the line in Star Trek to boldly go where no one has gone before, to me, is our pioneering spirit. It's how we moved from Europe into North America. It's how we explored the other continents. It's why we go deep underneath the ocean. It's why we began to fly through the air. And that's, yes, why we've gone to space. And now we're beginning to think about going to exoplanets like Mars coming up. Uh, those are the things that define humanity, is that quest to be innovative, that quest to explore, that quest to discovery. And that is something that we need to do across all of the different parties involved with this. So, Sharif, I hope that answered your question.
Mhm. Thank you, sir. My friend Mr. Markley joined today. Thank you for joining today's sessions. We are discussing about this NASA James Webb technology. So, what you want to discuss and what you want to share for
No
today's session?
problem. It's always fascinating to join you, Sharif. And of course, definitely there's been a lot of conversation around space exploration. I was actually just doing a show with a friend of mine in that gamer space. It's a show that he does around video games and things of that nature. But one of the things that he discussed, which I had not thought about, but I'd love to hear David's thoughts and maybe even Adam's thoughts, was that apparently some of these images we're seeing are actually and I do mean many, decades and even centuries and millenniums ago and all of that. So what we might actually be seeing amounts to the dinosaur ages of our periods. And so like if they were, because that's the way that our eyes and reflexes and the way that distance travels and all of that. And I hadn't really thought about that until my friend Jacoby, who was in that space of both being a science to some degree nerd, and I would definitely say a science fiction fan and everything, but it definitely made sense because he was even pointing out how if we were in the same room, we are actually seeing each other a millisecond apart from each other and all of that. So maybe even more than a millisecond. I'm not in the science space, but the way he explained it, it actually made sense and all of that because we are not seeing each other necessarily in the same time frame. We're actually having a little bit of distance travel ourselves, even when we are looking at our friends that we are having regular day-to-day conversations with and all along those lines. But I hadn't thought about that, but it did make sense as he explained it to me. And David is in that space, so maybe he can explain it more whenever he gets going, and Adam, and all along those lines. But I agree with something David said. We definitely need space exploration, and we definitely have had some great inventions from space explorations, even though, as I said last time, there's some things that I wasn't that big a fan of, even though we did use it and everything, like Tank and some of the other things that existed in that space and all along those lines. And we definitely know that we even sent, and I am a somewhat of an empath to animals, and we do know that we definitely sent the animals up before we went ourselves. So in some cases, we might have even, no doubt, we did sacrifice some of those animal lives and all of that, because we definitely sent monkeys, as did the Russians, I believe, and some of the other folks. And then we felt it was safe for mankind to go up there and begin exploring. And now we're looking at Mars, we're looking at maybe even eventually Venus and a number of other places. But as some of our past guests have said, there are a lot of issues that we need to deal with right here in the United States now and in the world. Now we can find those solutions through space exploration. I am all for it, and all along those lines. And I know one of the things we've been talking about, even with this climate change, is the role of water and how water can play, because there's definitely been a lot of conversation around wind energy, and I'm sure that we could also further explore water energy. And the earth is made up of mostly water, with the various oceans that are out there and all that space. So definitely I think that we should be further exploring just as much down below as we are up in the stars, because I think there's a lot of answers that we don't know that are in that water space as well, because we've only gone but so deep, and now we're sending drones and satellites and other things down in that space, much as we did with the animals that we send up to space. But now we're sending them further down into the water, and who knows what we may find. We may even discover the Loch Ness Monster down there, way down in the depth, if that creature actually exists or not. But yeah, big fan of science fiction, and I would love to see what's out there in the world, and if we're actually going to find some existing life form. And if we find it, if they're going to be looking at us like, hey, you humans are kind of crazy, we've been having these solutions solved a long time ago, or if they're going to be more like a primate version, where we are the ones that are further along than they are. And only time will tell. And, it might be millenniums before that happens. So I don't think that any of us four will be around, even though I hear that Dave is going for 500, but that's just what he's going for personally, and all along those lines. Now, whether he actually makes it or not, hey, you got to set those goals high. Adam, you're a younger fellow. I say you should go for 700 and all in that space, but let's go for 500, 700 and see what happens. I've jokingly said that I was going for 200.
Thank you. Mr. Adam.
Unmute.
You're on mute.
I think he has a bit.
Okay.
There we go. Yeah, I recently I was watching a program detailing how the James Webb telescope was built, and to see how meticulous its construction was, and how slowly and gently different components had to be moved, and seeing the scientists and constructors in these full body kind of like hazmat suits to prevent even the slightest contamination was really something quite special to behold. And the results of such care and attention were apparent in, say, those golden mirrors. And when I saw that, I thought, I was astonished. I thought, I don't think I'd ever seen anything quite as shiny and reflective before. It's a marvel of engineering that is not only advanced but also beautiful to look at, form and function in harmony. And so much relied on the expertise and knowledge and practical skill of people from across all these different fields of study and research and engineering, and learning about how the telescope was supposed to unfurl like a blooming flower, its sheets and foils, made me really appreciate the system of moving parts and complicated sequences that had to work just so in this particular order before that particular mechanism does this or that, and seeing how anxious the ground control were, waiting with bated breath as they were hoping and praying that it would work properly. And I think there was a few kind of tense moments where they thought something hadn't been triggered, and maybe it couldn't unfold properly, but it did, and so it gave me kind of a newfound appreciation for engineering and science, and it's possible for something to work, to be functional, but also beautiful at the same time. And I think we should all say a big thank you to to the team, the people who built it, and to NASA for having for bringing back these images for everyone to look at. And I think after the previous couple of years, they haven't been the best. Maybe these images could be part of like a cultural phenomena that will help help lift the spirits a bit. Like other people here, more so a Trekkie as well. And I think that kind of techno optimism is something I think that is possible and achievable. And see those images, it really puts things into perspective, and makes me glad that we were able to weather the last couple of years. And yeah, they've been a bit dark, and a lot's happened, but something like that is a ray of hope, really, seeing those photographs. And yeah, we are indeed looking back in time, because of course some of these objects and nebula and stars and galaxy are billions of light years away. So we're looking back through time, and that really adds a whole new epic dimension to it. So it kind of reminds me of the topic of life extension that we talk about sometimes, and people criticize it by saying, "Oh, wouldn't you get bored if you lived hundreds, thousands, millions of years?" And I think when one sees images like that, and how every speck is a galaxy of billions of more specks, and how many of those have solar systems, and maybe each planet would be unique in its own way, different makeup, different ecosystem if they have one, new elements. There'll always be new things to discover. So yeah, I think we've seen a lot of really interesting stuff so far, and I'm quite excited for the future.
Yeah, and
Thank
the
you.
other question I've always heard people ask, and I don't know your thoughts or even David's thoughts as well, is that when it comes to time travel and some of these images of going back in time and going forward in time, even, is that this notion, and it definitely was a theme within science fiction novels and everything, of you losing connection with the family body that is the body that whether that's your grandparents, your parents, your brother, sister, whatever other family members you may be fortunate to have. If you're fortunate enough to have kids, of which I am not, but I do have my nephews, and you're used to that time span. If you are able to go into that distant future and everything, what would life be like in that space? I know there's always the story in science fiction of the person that comes back and doesn't recognize the earth that they left and everything. Like if somebody was to come back from 200 years in the past and things of that nature, they would maybe 100 and 150 years, they would be dealing with slavery, and then maybe some of the Wild West stuff that we don't have as much of. I won't say that we don't have it, but we don't have as much of it as we did during those time frames. So I'm just wondering both of your thoughts about that, and will we ever get to that point of actual having time travel and or travel in through space and dimension, which is something that people oftentimes talk about, or is this just something of science fiction that will never become a reality?
Mhm. Thank you.
Mark, I thought you were from another dimension.
Oh, you did
So,
know? Yes.
but Sharif, let me answer one of the questions here, because it really, Mark brought up a very interesting point before. Now, as you look at the speed of light, which is what we're imaging in the James Webb Telescope, and there's differences that you look at with the frequency of the light. And one of the special things about the James Webb Telescope versus the other ones we've had in space is it can do very long waves, up in the deep infrared area. But you asked a question about the people you were standing next to. The speed of light uh, travels 1 foot in 1.0 nanoseconds. It travels a meter in 3.3 nanoseconds. So from the Earth to the moon, it's 1.3 seconds as you look at the speed of light. But to kind of let me put it even in a broader context, the speed of light is 299,792,458 meters per second. So the images we've seen are from a long time ago. And you'll see them if you base on the speed of light. The speed of light came up in Albert Einstein's theory of special relativity. And then, Mark, the other things you were talking about there with time travel, multi-dimension and stuff, actually was addressed by Einstein in that theory of special relativity and the extensions he later published to it. And we've seen more and more of things like that being proposed now as we have a better understanding of science. You know, we now understand that black holes might be a way to travel through space that allows us to beat the speed of light, to beat the things we do. Because many years we thought that the speed of light was the absolute maximum speed, and we're learning it's not. We also thought that the speed of light was a constant. And in the labs today, we have brought the speed of light down to 32 miles per hour using at absolute zero in a pure vacuum. So we understand there's nuances and uh, the our view of science is continually changing, which is fantastic. You know, you've heard me use the example in past. I am just so glad that we don't use sticks and stones to plow our fields anymore. I'm really glad we don't have to carry our crops on our back and beat them by hand to make crops because we've continued to evolve. We're doing the same thing in space today, and we're enhancing that understanding. And again, I want to repeat what I said earlier. Space exploration is not just the large countries. It really is an international collaboration working together. The war in Ukraine is threatening part of that, and I hope it does not. But even that, most of us think about the International Space Station. There's actually a Chinese space station in space too. They released last week the first picture of a space telescope that's going to be in the order of Hubble, not the James Webb, that they are launching probably before the end of the year, if not early next year, into space. So we're doing everything we can to advance the science of space, to advance the knowledge of our humanity. And looking at photons that are million or billions of years old can help us understand our future. It helps us understand how we were created, where we're coming from, and what might be our planet's ultimate destiny. So that is why things like the Webb telescope are so important, and why people around the world in universities and countries and other areas can participate. The NASA, which is administering the WebCon, has made the data available internationally for people to analyze, use, and learn from. And to me, that is the important things for us to do. So, Sharif, I hope that answered Mark's questions and added a little bit more.
Thank you, Professor David. With Professor Donald, we are discussing about NASA James Webb. So, what the interesting information you want to share for our audience?
Well, I'm sorry I missed what others said because I know that David usually lays an incredibly good foundation and is very knowledgeable. So, and Adam, so I'm probably being redundant. But one thing I want to say is how incredibly exciting I find it because so far we've gone back about 13 billion years, and when it's completely tuned, we'll get back about 13.5 billion years, and the universe is about 13.8 billion years. So we'll be about 300 million years after the beginning of the universe, which is getting, I mean, relatively, that's pretty close. And at the beginning of the universe, everything was just energy. And the energy coalesced into into particles. It's kind of an interesting thing that the universe is made up of these fields. So there's fields that are photon fields, and there's fields that the famous field is the Higgs field, which is the CERN reactor. Um, uh, basically what happens is when there's enough energy added to one of these fields, then the particles pop into existence. And it's kind of interesting why they stay in existence after they popped into existence. In the complete vacuum of space, there's energy, and that energy pops into existence and pops out of particles pop into existence and pop out of existence. And that's the lowest quantum state in our universe. So there's an interesting thing that's related to the Big Bang, and it's related to our universe. The lowest quantum state in our universe still has energy, and we have this idea that we could open a hole into a universe with lower quantum state than our universe. And if we did, the quantum state of our universe would change to this lower quantum state. And at the speed of light, our universe would just basically go away. It would change to this lower quantum state. So I think that's a pretty cool, interesting idea. But regardless, so what happened was when the Big Bang happened, these first various particles started coming into existence, and then they started coalescing into atoms. And the first atoms that were created were hydrogen atoms, and then the hydrogen atoms coalesced into helium atoms, and over time they coalesced into stars and galaxies and all these kinds of things. And if we look far enough back in time, we just kind of see this mush of everything coalescing. And we're getting back far enough already that we can start seeing the very first galaxies. And we're eventually going to get back to the point where we can really start seeing these galaxies being formed at the very, very beginning of time. And I mean, that's incredibly, incredibly cool. I mean, that's amazing. And one of the other really amazing things about it is that we predicted this is what we were going to see to a large degree. And when we went and looked at it, lo and behold, we saw much of what we expected to see. So that means that there's the other picture, the one of where you see the bright stars in the middle. Maybe keep going. No, keep going. That one, yeah, that's the one where the one we just saw. That one right there. That's where we're looking the farthest back in time. That's where we're looking at the galaxies that are 13 billion years old. And the stars that kind of have radiance around them, those are stars in our galaxy. Those are actually stars. But the fainter dots of light that don't have radiance around them, those are ancient galaxies. And we're seeing galaxies there that we've never seen before. The Hubble telescope couldn't see them. And so, it's just amazing. When those pictures were revealed, I was watching a live stream on TikTok from an astrophysicist, and she was the most amazing, sweet woman. She was a young graduate student in astrophysics, and she said, "I might cry," and she did. She was so excited, and um, it's this is just stunning that we can see this, and it's going to get better. The what happens is there's I forget the exact number, a zillion of these teeny weeny little telescopes that are all um, directed, and they're all tuned together to look at various places in space. And what we're seeing now is if you took a grain of sand and you put it at arm's length, that's how much of the sky we're seeing in this picture. So basically, just take a grain of sand and hold it in your finger. That's how much of the sky that this is. Um, so, and I'm sure other people explained it, but there, it the the telescope is at a place called the Lagrange point, and what it is it's the place where the gravity of the sun and the Earth are equal to each other. So it just kind of sits there. It, it circles at the same speed as the Earth, so it goes around the Earth exactly 1 year, just as the Earth, same speed as the Earth, and that way it's stable because the Earth's gravity and the Sun's gravity both pull at it at the same amount, so it just is stable, and that's about a million miles from Earth, and it was all folded up, and it had to unfold in space, and the engineering is just, I can't even comprehend how complicated and perfect that had to be. It's just one of mankind's just unbelievable achievements, and the beauty of it is, incomprehensible. And one of the things that excites me is the in the universe there's what's called dark matter and dark energy, and we know that the universe is expanding faster than is accountable by the amount of mass that is in the visible mass that's in the universe, and we can calculate that. And so there's some energy that's in the universe that we can't see, and we also know that certain galaxies and planets and other things are being affected by mass that we can't see. So that's dark mass. And so when we look, what we can see is affected by photons are affected by what we can see. And so all of the particles that we know about in quantum physics are affected by photons. So what's happening is there are particles that exist that we don't understand, that are not affected by photons, but they have mass. So we don't know what they are, but there's more of them in the universe than there are particles that we can see. And so hopefully with this wonderful JWST, we'll be able to uh, start comprehending that some of the aspects of the universe. And it ties to quantum physics, which is when I was talking about the early part of the universe where energy was converted into, actually started converting into matter. That's the point where we're really talking about quantum physics, because, as I said, there's these quantum fields where particles pop into existence, and that's the kind of core of quantum physics, what's called quantum field theory. And so hopefully we'll be able to tie the two together and really start understanding what the universe is made out of at the teeniest level and at the biggest level. So it's incredibly exciting.
Thank you, thank you, Professor David Smith. Actually, these images actually create a lot of things in social media. So if you discuss uh, about these images and share something about our these images with our audience, maybe it will be helpful for them. Yeah.
Well, I love the images you've been going through because in the past, you only saw a couple of the bright stars on this particular image. You didn't see the cloud nebulas there. And what you can see with this is that you can see actually stars are behind the cloud nebulas and stuff. You can begin to hear it. This is a composite image of multiple spectrums put together. The new ultra wideband infrared imaging that's on the Webb telescope that has not been on any of the telescopes in space before is what gives us the ability to see the details beyond the visible light and be able to understand that. Um, and it really uh, gives us the insights to understand that this nebula is massive. That the possibility of other worlds out there is uh, unfathomable to us, really, as we try to put numbers to it. Donald, I love Donald bringing the other parts of science into this because that really what it is there. Um, and and when we see those, I can go back and look at all the different things from the Einstein. Uh, there you see the Bohr, the Einstein, others that have put the science and space around this. And just the extreme amount of how do you create a flexible mirror? How do you create it to where it can fold up and then expand to 21 feet in diameter, made up of all these different mirrors? How can you align them using artificial intelligence and artificial measurements in space? How can you begin to look at ways to communicate back with that? One of the interesting things on this is the size of the hard drive on the James Webb Telescope is tiny compared to what we can do today. Our cars have a lot more storage in them than the telescope, but we're able to get this extreme high resolution and this detail. And again, not just in one band, but in all these multiple bands, and capture them, store them, transmit them across this 1.6 million miles of space back to the Earth and download and analyze and share. Um, it's just really amazing to me. You know, I grew up when man first went to space. I was alive when Sputnik was launched. I was alive when the Apollo, well, when the first John Glenn went into space for the United States. When we went into orbit, uh, my grandparents and my mother worked for the company that made the first EV suit, where you actually got to step outside of the capsule. And I got to actually put them on and play with them. I in one of my trips to NASA Houston, we were walking around with the director of NASA and others, and he took us into one of the labs there where it was a simulation you could do being in the payload bay of the International Space Station. I love that one because I got to put in the suit, walk around like I was in zero G, but then there was a glitch in the software. My body was half in the space station, half out. And I asked them what side they were going to amputate to please keep it the good side. But you see that you're able to experience the NASA programs where students in classrooms globally, not just the United States, but globally, can talk to the astronauts in the space station, who can go into a lottery and send their experiments up to space and get the results back. That to me is creativity and innovation at its height. And that's the Webb's uh, telescope is just advancing our fundamental knowledges not by small steps, not by incremental steps, but by leaps and bounds. And that's what's so important.
Thank you, Mr. Adam. Regarding this, like pictures, like if you had something, maybe it's helpful for our audience, Mr. Adam.
Yeah, Mark's question highlighted the issue of culture shock. But of course, technological innovation has improved exponentially, but I think we may have reached for the first time a social phenomenon where a single individual lives through a multitude of cultural changes and tectonic social movements where what is popular and what is not changes and then comes back again before flipping back once more and so on. And I think the stress of that can contribute to much of the malaise found in today's peoples. Secondly, I really liked what David said about countries and space programs. What are the countries that appear immediately in one's mind when they hear or read the word space program? The USA and Russia, of course. But now we have India launching rockets, the Chinese building space stations, like David pointed out. Uh, Puerto Rico is home to the Arecibo dish, which is the dish is owned by NASA, USA, of course, but still. And so that begs the question: how much talent is being wasted in poorer third world countries because they never had the appropriate boost or resource or opportunities, um, and lots of wasted talent in affluent countries as well. But to answer that, I think a lot of talent is being wasted. Surely, statistically, every nation, large or small, rich or poor, has at least some people who could help to revolutionize astronautics or drive innovations in astrophysics and so on. So that is one of the positives of the current day and age is that this shortcoming is being recognized. So maybe unification is a necessary prerequisite before we can enjoy the privilege of actually visiting the places as shown in these photographs, visiting and flourishing. Certainly, we want to go out there and try to terraform a planet while still being affected and weighed down by humanity's destructive impulses and negative characteristics. We must help ourselves before we can go out and help whoever else is out there.
Thank you, Professor Donald. What's your concluding remarks for today's session?
I'm very positive about exploring space. Uh, However, I really support what Adam just said. Is I don't I think that the value of sending people up there is very limited because people are heavy and they're expensive to send up in space. They're not they're not adapted to space, so we have to send a lot of equipment up there to have them be in space. It's exciting, but the like even if you could get say for an instance an atmosphere on Mars, it would be an atmosphere that would be is I mean, in the best circumstances, from the gravity of Mars, it would be an atmosphere that would be similar to the top of Mount Everest, which is very difficult to breathe. And that's in the best circumstance. And you might argue that, well, you could adapt to that kind of an atmosphere and things like that. I think that Mars would be similar to a book called The Three Stigmata of Palmer Eldritch, which was by my favorite science fiction author, Philip K. Dick. And in it, they basically sent prisoners there who lived underground and mined, and it was just this horrible life where people, had extremely limited thing to do, and they just lived underground in this miserable circumstances. And I think that that's probably the best you could do on Mars. So I don't see, and the amount of energy that it would take to get to another star is quite out of our reach right now. So it would take generation. We'd have to build spaceships where people lived on for generations, and we can't do that. So anyway, I don't think that. However, I think that the James Webb Telescope, I prefer calling it the JWST, and that's kind of gotten to be the because James Webb was quite an asshole, and pardon my French. So people have gotten to call it the JWST. It was kind of a mistake naming it after him. But so the JWST shows the kind of engineering that we can do. And the engineering, doing that kind of space, that kind of work in that kind of space exploration that we're doing on Mars, like the Martian lander has been driving around Mars far longer than we expected it to, and so we can. And when we engineer things like that, we learn so incredibly much that it percolates out through society and creates value, extraordinary value beyond the actual space exploration itself. So and as everyone's pointed out, it creates ways that we learn to collaborate globally between different countries and the world itself. So besides the incredible things that we're learning, now, I want to just say that David mentioned something about a lottery for scientific experiments, and that's kind of what they're doing with the JWST, is that people basically queue up to have their scientific experiments done. So there's a line of scientific experiments that are being done on JWST. The people that are being done, you get in a queue, and I don't know quite how you get it, but a lottery seems like a pretty fair way of doing it. And it's global, so people from France or Bangladesh, as far as I know, can run experiments on that telescope. So it's international collaboration. It's incredible technical and engineering advancements. It's increase in knowledge, and I think that it's a prototype in a way of the kinds of things that we can be doing in space. And so it's incredibly exciting and wonderful, and I hope we keep doing stuff like this.
Thank you. Thank you. Mr. Adam, what's your concluding remarks for today's session?
Yeah, I would say to people, don't let the vastness of the universe, as demonstrated by these images, make you feel small or that you don't matter, because you do matter. You are not small. You are important to you and your family and your friends. Everyone has problems in their lives. Don't let the great size of space and the objects in it make you feel like anything that is affecting you, both negative and positive, is simply trivial in the great scheme of things. Let these photos lift you up, raise you up, and let them inspire you to face life's problems head on, find resolutions, rather than ignoring these problems in apathy because you think you're just a blink of an eye or a speck of dust. We're all, each one of us are more than mere specks or blinks, don't ever feel small, and find inspiration and to live your best life. Yeah, thank you.
Thank you. Mr. Martley, what's your concluding remarks?
Well, I'm glad that I was able to pop in. I was actually having a couple of meetings and everything, and I was actually also double checking to see how we look on Roku, and we all look good on Roku because I was actually seeing that my Roku TV is up and running, and definitely the conversation is there. So everybody is looking smart and wonderful and looking amazing and all of that. I was definitely making sure that it was running and going on to the network. So David and Donald and Adam, y'all are all looking like excuse me, fantastic stars, and Sharif as well. So definitely it's just that star moment. Speaking of stars and all of that. So y'all are having that star moment in that space as part of Pod TV and all along those lines. But as far as space travel, I'm actually definitely looking forward to some of the gains, as I said earlier, that we will be getting from this continued space voyage and space travel, and definitely kind of like the exploration of space, even through the telescopes and other things. I'm still, along with David, trying to figure out how much the tickets are going to cost and whether I actually want to go up in space. Because by the time we actually get up there, I'll probably be like 90 or whatever. And then I'll have to get like the discount senior ticket and all of that. Adam will only be about 50, so he won't get the senior discount. But me, David, and Donald, we might get the senior discount for traveling up into space and all of that. Sharif, you won't get a senior discount either. Sorry to tell you that. So no senior discount for Sharif either. But definitely looking forward to seeing what this will all be looking like and whether we're actually all going to go up in space at some point or another. It's like any other thing. I just went on my first cruise about 3 years ago, and while I liked the cruise and might want to go on another one, there were aspects of it that I didn't like the aggressive salespeople that were there, and sometimes the choppy water. So I'm imagining that space travel might also have its choppy moments as well, like if a meteor goes flying by you or something like that. So I might have to get prepared for that aspect of it also. But we'll have that conversation at a further time and all along those lines. Because, like I said, I have a somewhat fear of heights, which doesn't go good for going up into space and everything. But then again, it sounds like such an adventure that I might have to conquer that particular fear and all of that, even those fear of tight spaces. But it's a big ship, so I'm not as worried about the tight spaces as I am about the heights and all of that. Can't be as brave and bold as Adam, who has probably gone skydiving and hang gliding and done all that other
I've
amazing
once,
stuff
yeah.
that I haven't tried yet. What'd you say, Adam?
I've skydived once, yeah.
Cool. Like I said,
It
more
was,
bolder than me, and all
it
along
was
those lines. But
frightening. It was,
might have to
yeah.
try it.
That would do it.
Thank you,
No
Mr.
problem.
Markley, and I want to give a special thanks to Pod TV to collaborate with World Talent Economy Forum. Professor David Smith, what's your concluding remarks for today's session?
Well, Sharif, great program. Mark, I have a timeshare I'd like to sell you on Mars.
Okay.
But Adam, I really 100%, 1,000% appreciate your last remarks in this. This
Wait a minute.
particular,
That timeshare, you said I was in another dimension, so I thought you had already sold me the timeshare from the other dimension because you said earlier that I was
I'm
from the
just
other
gonna,
dimension.
I'm going to bill you from each of the dimensions, so you know it's residual income.
Okay.
Uh, but Adam, you talked about the hope in the future. This has been a tough week for me, and those words actually had a special place to hit me. So thank you. I'm going to have one of my shortest closes ever, Sheree. And what really impressed me with all the images were not the close-ups that you talked about there, but there was one image that was their first deep fill, and that's the one with a couple of the bright stars in the middle. You had those. You had the warped light timelines, which looked like uh, comets moving through space, and you had thousands upon thousands, not just of stars, but thousands upon thousand galaxies they shot from that. And you know that has been touted as the deepest image of the universe ever taken. But there's one of the scientists working on this, Scott Gowdy, who's an astronomer at Ohio State University. And I loved his comment, and I'd like to close with his comment if I can. He said, when you start looking at that image, the deep field image, you realize there's no blank sky. You look at that image and see the thousands upon thousands, millions upon millions, billions upon billions of stars, galaxies, planets in those. And that there is no blank sky, which just was a comment that I had to step back and really think about. And that's what the telescope is doing. And I liked his really last quote. There's something crazy happening everywhere in the galaxy. In my last comment is the galaxy's perpetually in motion. we're perpetually in motion. Our body, each of the molecules, each of the atoms are perpetually in motion. And the scientific spin out of this telescope will help us understand a deeper understanding of everything around us. So I'm jazzed about it. I can't wait to see it where it goes. And yes, Mark, I would love to sign up to go into space and be part of that. But it's really a great show, Sharif. Thank you so very, very much for being part of it.
Thank you, everyone. You know that World Talent Economy Forum, our major targets that we want to create a knowledge-based society in the developing nation with the help of developed world. So I want to give thanks those who regularly attend World Talent Economy Forum as a speakers because they voluntarily support all of our initiative. And beside that, what we learn from today's dialogue, we take action as an institutions, and we are trying to help more. Youth from Asia Pacific. So hopefully we can bring more interesting projects. Me and Professor Donald also working for one of the important project. Hopefully we will declare soon for doing this project. So I need more of your support, and I request all of our audience, please share our content with your government, with corporation, and with academy. And especially I want to give thanks the Pod TV for collaborate with World Talent Economy Forum, and beside that, East South Asia Web TV from South Asia. They're also supporting our initiative. So thank you everyone for joining today's session. Thank you, bye bye, and take care.
Bye, everyone.